Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. Class 10th Mathematics. It forms the base for higher mathematics in class 11th and 12th. So, knowing all the concepts, practicing the questions and the various models of questions is really important. In this video, I am going to take up the very important fundamental theorem of arithmetic, which forms a very important part of the class 10 board exams and the problems based on HCF and LCM. So this is especially important for my class 10 students and all those who are preparing for various quantitative aptitude exams. Let's see what we have in the video, and before that let me just tell you about the app which we launched very recently, the Learning Loop app. This is the logo you will find on the app. Download the correct thing from the Google Play Store. The link is given here in the description box below, and you can buy very nominal costing validity based video courses. So if you have not yet prepared for your class 6 maths, 7th maths, 8th maths, 9th maths, 10th maths and 10th science, Vedic mathematics, the short tricks, we have everything on this Learning Loop app. You can purchase ebooks, you can see video courses, you can see some free stuff also in the form of some videos. Learning Loop app you can download now. Let's see the concept in hand first, the fundamental theorem of arithmetic. So what is fundamental theorem of arithmetic? You all know that the numbers are categorized into two different types of numbers based on their divisibility. So if a number is divisible only by 1 and by itself, that means it has only two factors, the number 1 and the number itself, then it is known as a prime number. I think that's a pretty elementary concept, right? Apart from the prime numbers, we have the other set of numbers which are not prime, that means which have more than two factors. Just like if I take the number 4, it is divisible by 1, divisible by 2 and divisible by 4. So it has three factors, more than two factors, right? Likewise, if you take 10, 12, 14, 18, 24, 36, all these numbers have more than two factors. And those numbers are known as the composite numbers. I think this we have studied at the junior level and we all know this concept, right? So the FTA or the fundamental theorem of arithmetic, it states that every composite number, so we are talking about a composite number, okay? So every composite number can be expressed as a product of primes. So let's write here, a composite number can be written as a product of primes. And that's why I told you the definition of prime numbers and the composite numbers first, because without knowing these two concepts, you will not be able to understand what is FTA. The product of primes, right? So let's take an example. Suppose I have the number 12. I can write 12 as 2 times 2 times 3. That's 12, right? Somebody else will write this product as 3 times 2 times 2. And another person will write 3 first and maybe a 2 first, then a 3 and then a 2. So, primarily the factors which we are writing, the prime factors which we are writing are same, 2, 2, 3, 2, 2, 3, 2, 2, 3. But the order in which we are writing those prime factors differ, right? So, there are some characteristics which are stated in FTA. The product of primes is unique. That means you can write a composite number in terms of its product of primes only in one way. It's unique. But the order in which we write the prime factors can differ, like these three. So, order can differ. Order may differ. Now, this is what we call the fundamental theorem of arithmetic. So, every composite number can be expressed as a product of primes. This product is unique, but the order in which we write those primes can differ. Pretty easy, right? Now, based on this FTA, we have a huge number of questions, and I'm going to take up most of those type of questions in this video. So you got to watch the entire video and learn what are the various types of questions which may be asked in the board exams, right? Let's see the first question in hand. Finding the missing number. A very important, again, 1 mark question. Examiners invariably target these type of questions. Look at this tree diagram here. We have A, B, C, D, 4 variables here, and there are some known numbers, and you need to find what comes in place of A, B, C and D. How do you find it? See, from the top we cannot start directly because we don't know what is the first number which is divisible by 2 and which gives some unknown number. So it's impractical to start from the top, right? So I'll start from the base here, the last number here, because I know it, that is a known number. Now whenever this and this numbers are given to you, it is pretty easy. What you have to do is to just multiply these two numbers and get our required number here. So 5 times 5 is 25. This will come here. And now once we know this number and we know here, this is the divisor, right? 3 divides B and gives you 25 as the quotient. So 25 times 3, this becomes 75. 75 times 2, this becomes 150. And 150 times 2, this becomes 300. So practically the missing numbers are A is 25, B is 75, C is 150 and D is 300. Again, a easy concept, and this 300 actually is written in its prime factorization form 2 times 2 times 3 times 5 times 5, and that will automatically give you 300 as the composite number. This is how you find the missing numbers. Likewise, a concept of HCF and LCM which you can't just escape in the board exams. Whenever you are given two numbers and you are asked to verify this, I tell you this is one of the most important questions which can be asked in board exams, and no quantitative aptitude exams will not have such questions. Every exam will ask you questions based on LCM and HCF. So the first thing is how to find the LCM and HCF using the fundamental theorem of arithmetic. For that, you should know what are the factors of 336. I mean, you should know how to express 336 in terms of its prime factors. So I am going to write 336 in the form of prime factors. Using the tree diagram you can make the factors, right? So 336 is divisible by 2, right? That will give me 168, correct? So again 2, 168 means divisible by 2, right? 84, again 2, 42, again 2, 21, 3 and 7. So I found these factors orally because I can do it orally, but if you can't do it, you can do it like this. 336 divisible by 2 gives you 168. Divisible by 2 gives you 84. Divisible by 2 gives you 42. Divisible by 2 gives you 21. And likewise you can continue and write 3 and 7 also. Right? So, here this can be written as 2 raised to power 4, 3 raised to power 1 and 7. Correct? Likewise, if I want to write the other number, which is 54, how do I write it? It is divisible by 2, right? So gives me 27. 27 is 3 times 3 times 3. And this becomes 2 into 3 raised to power 3. So you have to write the numbers in the form of the prime factors and then write it as exponents here. Now let's learn the rule how to find the LCM and HCF using these exponential forms. When you have to find the LCM, how do you find the LCM first? The common factors, like we have a 2 here and a 2 raised to power 4 here, right? So the higher power 2 raised to power 4 will come in the LCM. Likewise, a 3 here and a 3 cube here. The higher power is 3 raised to power 3, so it will come here. And finally, the uncommon factor. This is the uncommon factor which exists in the first number, not in the second number. That will also be a part of this LCM. Okay. Now, these factors are to be multiplied. So we have 2 raised to power 4, which is 16, and 3 raised to power 3, which is 27, and 7, and that will give us the product. So I have already found it for you. It is 3024. The product of 2 raised to power 4 16, 3 raised to power 3 27, and 7 is 3024. Likewise, if I have the HCF, so I should know how to find the HCF now. If I get the HCF correctly, then great chance that I am going to crack this question very easily. HCF is when you take the common factor like 2 raised to power 4 and 2, take the lower exponent. So 2 raised to power 4 has a higher exponent, so 2. 2 will form a part of the HCF. 3 and 3 cube, 3, because that is the lower power, and there is nothing else. Why? Because 7 is an uncommon factor. So uncommon factors are never considered in HCF. So here we have only 3 and 2, and therefore the HCF is 6. So now I know the LCM, I know the HCF, so I can safely verify LCM times HCF, is it equal to the product of numbers? Let's verify LCM times HCF. If you see 3024 and 6, this will give you a product of 4, so 2 carry means 14, 4, 1 and 6 3s are 18. And likewise, the product of numbers, the numbers which were given in the question, they were 336 and 54, so 336 and 54. Just multiply these two numbers and I am sure you are going to get the same result. So if I check it, I do get 18144 as the product, and therefore my question is complete because I have verified that LCM times HCF is equal to the product of numbers. This is the second and the very important part of this particular session. Let's see another question. So we have two numbers here, 404 and 96, and the HCF is given in the question as 4. We need to find the LCM. So again, the same rule works for us here. LCM times HCF is equal to the product of numbers. Now once you know that rule, I think the question is not going to trouble you. So how do you find the LCM? We can actually find it directly because we know that LCM times HCF is equal to the product of numbers, right? So let's put whatever is known. LCM is not known, HCF is 4, product of numbers, the numbers are 404 and 96, and therefore the LCM will be 404 times 96 upon 4, and the 4 cancels this 101 times, thereby giving you 101 times 96, which is 96 as the answer for the question. That means the LCM of 404 and 96 will be 96. Very easy, right? Again, a very important question for 1 mark, or objective type, maybe multiple choice question. Let's see the next one. Again, very important for quantitative aptitude exams also, SSC, CGL, banking, railways exams, they ask you such questions. Can two numbers have 18 as their HCF and 380 as their LCM? So whenever there are two numbers, I mean one of them is HCF and the other one is LCM, and they are asking you to verify whether it is possible or not, then the important concept to be used here is HCF is always a factor of LCM. A factor of LCM. This is the concept we need to use here, and you just need to verify whether this HCF 18 actually divides the LCM 380 or not. If it divides, the possibility of 18 as HCF and 380 as LCM exists. But if it doesn't, that means it is not possible. So let's check whether 380 is divisible by 18 or not. So I think there is a common factor 2, so this becomes 190 and this becomes 9. And now there is no other common factor. 190 is not divisible by 9, right? And therefore the answer to this question is no. Because HCF is not dividing the LCM, this is not possible. Another important question here. Explain why 17 is the first term and then we have a big term here 11 times 13 times 17 times 19 is a composite number. We have to check why is it a composite number. So one of the things you can do is to simplify this, which will take a lot of time because multiplying 11, 13, 17, 19 obviously is not easy, right? So there has to be some trick. There has to be some logic to call it a 1 mark number, 1 mark question rather. So let's explain why it is a composite number. We already know that it is a composite number and that means it has to be divisible by some number with apart from 1 and itself, right? I told you there are 2 terms. Can you see that there is a common factor here 17 and when I take the 17 out I will have a 1 here plus 11 times 13 times 19 here. Now I don't know what is this number. Let's call this number as 17. This is 17 already and this number as x. Okay. Now when I have represented a number as 17 times something, it means that the number is divisible by 17. It is already divisible by 17 and when a number is divisible by 17, that means 17 is the third factor and therefore it is a composite number because once you have a third factor, that means the number cannot be prime. And so we can safely say, so you have to write some English sentences here to get 1 mark, right? So you have to write, since it is a multiple of 17, it is divisible by 17. So 17 is the third factor and therefore it is a composite number, right? Let's see this one now. Again based on the same thing, LCM times HCF is equal to the product of numbers. Say the numbers are A and B. Let's see what is given. The HCF is 9. So let's put here 9. And the LCM is 360. So let's put here 360 equals, if one number is 45, so let's call A as 45. We need to find the other number, that means B. And pretty simple now. I think if anybody can do it. So B or the other number will be 360 times 9 upon 45. 9 cancels this 5 times and 160 upon 5 will give me 72 as my other number and therefore the other number is 72. So as you can see friends, whatever questions I have taken now, the fundamental theorem of arithmetic works here, how you represent a composite number in terms of its prime factors. And these are the models of questions which you have to work on, and I'm sure if you follow all the questions, practice all the questions which I have given here in this video, the fundamental theorem of arithmetic part is going to be really strong, and LCM times HCF is equal to product of numbers. That is the takeaway from this video. Work on that, solve a lot of questions, and I'm sure it is going to benefit you. So friends, do share this video with all those who are struggling in class 10th concepts. Even for higher exams you need these concepts. Do subscribe the channel if you haven't done till now, and along with the subscribe button you will find the bell shaped icon, and you got to press that bell shaped icon and press all notifications to get all the notifications of future uploads on your mobile phone so that you don't miss out on anything. Friends, thanks for watching this video. Do look for more such amazing videos in future also. All the best.